Hello YouTube, welcome to this video, and today we are going to be tackling a problem where there are two small spheres, each positively charged, and they're situated 2 meters apart. And we have to decide, where do we place a third charged object of the opposite sign and whose charge is 3 times 10 to the negative 6 coulombs, such that it experiences a net electrical force of 0. Alright, now the real question we are going to be answering is, do we really need to know the charge or sign of the third object? Nevertheless, I will still go through how to numerically solve where to find the location where we're going to place the third object so that it experiences no electrical charge. Alright, without any further ado, let's get started. So first, let's draw a diagram of this scenario. Alright, so if we have one sphere here, we're going to call that Q1. Alright, and then some distance away, or some 2 meters away. Alright, I'm going to have my 2 meters there. Okay, 2 meters, 2.0 meters. We have a second object. We have Q2. Q1 has a positive charge of 1.6 times 10 to the negative 5 coulombs. And then Q2, that has a charge of 6.4 times 10 to the negative 5 coulombs. Now, we have to place Q3 somewhere between these, somewhere within this 2 meters. So I'll just draw a circle there, and we're going to call that Q3. Alright, so now let's start formulating the equation. Essentially, the net force on Q3 is going to be 0 newtons. Therefore, the forces on either side must equal in magnitude to be able to cancel out. Alright, so basically there would be a force this way, a force that way, opposite direction, equal magnitude, therefore they cancel out. Alright. Anyway, coming back to the equation, we're going to have the electric force that 2 has on 3. So we're going to be talking about this force vector over here between Q2 and Q3. Alright, and that is equal to Fe 1,3, the force that 1 and 3 are exerting between each other. That the magnitude of that vector. Alright, so now the electrical force formula, we got to know that. So for the left side, that's going to be K times Q2 Q3 over R23 squared, the distance between object 2 and object 3 squared, is equal to K times Q1 Q3 over R13 squared. Alright, now we have this, we have formulated this equation, and well, we can already start to cancel things out. So I'll do that in red. Okay. The K is on either numerator, that's gone. And Q3, that's on either numerator, so that's gone. Alright, so we are left with Q2 over R23 squared is equal to Q1 over R13 squared. Well, that answers this question here. Do we really need to know the charge or sign of the third object? Well, to answer this, that's a no, we do not, since it got cancelled out. Alright, so now let's carry on with the rest of the question. Okay, so now we're going to have Q2 2 over R23 squared is equal to Q1 over R13 squared. So now that we have this, we'll be able to solve this after we plug in Q1 and Q2, right? But the thing is that R23 and R13, they're different variables. Let's try to write R23 in terms of R13. So we have R13 over here, and we have R23 over here. And object 1 and object 2, they're separated by a total of 2 meters. What we can do, we can write R23 as 2 minus R13. Because if you think about it, you have 2 meters here, that's a long 2 meters, and then you have this distance here of 1,3. If you do 2 minus R13, you get R23. There we go. Alright, so now let's just plug in Q2 and Q1, so that would be 6.4 times 10 to the negative 5 coulombs over R23, which is going to be 2 minus R13 all squared. That's going to be equal to 1.6 times 10 to the negative 5 over R13 squared. And we can cancel out a few things here. We can cancel out the 10 to the negative 5 coulombs on either side. So let's just go and put a red X through it. There we go. Now we can solve this using eventually the quadratic formula. But first we have to do some rearranging. So I'll continue this on the left side over here. Let me do that in blue. So if we cross multiply, we will get 6.4 times R13 squared, and that will equal to 1.6 2 minus R13 all squared. Alright, now if we were to go ahead and simplify this further, we would go with 6.4 R13 squared is equal to 1.6, and we'll expand the brackets using FOIL, so that's going to be 4 minus 4 R13 plus R13 squared. Alright, and if we simplify this further, that's going to be 6.4 R13 squared is equal to 1.6 times 4, that's going to be 6.4. 6.4 minus 6.4 R13 plus 1.6 R13 squared. And then we can solve this, of course, using the quadratic formula. So we have to make this equation equal to 0 on one side. So we're going to put 0 is equal to, we're going to subtract 6.4 R13, subscript 13 squared. We're going to subtract that from the right side of the equation. So we're going to get on the right side then 6.4 minus 6.4 R13 minus 4.8 R13 squared. Okay, 1.6 minus 6.4 is minus 4.8, hence why we get this value. Alright, so now we're done this part. We've gotten down to the equation. All we got to do is now plug this into the quadratic formula. So I'm going to go to the next page and we're going to plug this in. We're going to do R13, the distance from object 1 to object 3 is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. R13 is going to be equal to, that's going to be minus 6.4 plus or minus square root of b squared, so again minus 4 squared minus 4 times A times C, and then that's going to be all over 2 times minus 4.8. If we plug this into the quadratic formula, we get two answers. One of them is minus 2 meters, and the other one is R13 is equal to 2/3 meters. Alright, we have two answers here. We got to decide which one is inadmissible, and it's pretty obvious in this question. We are going to be striking out the answer where we got minus 2 meters. Therefore, the third object is 2/3 meters away from the first object. Alright, so basically R13 is equal to 2/3 meters. There we go. Well, so that's it for this video. I hope you were able to get a lot out of it. And if you enjoyed it, please consider liking, subscribing to my channel for more videos like this. And, well, thank you for watching and have a wonderful rest of your day.